So what's up guys, welcome to Venom Prunov Academy, and in our today's video we are going to look at rational numbers. Remember from the previous video we described what rational numbers are in a jiffy, but today we want to go into details about these numbers. Okay, remember we said rational numbers are simply numbers that can be expressed as a fraction in the form of a over b, where both a and b are members of integers and b should not be equal to 0, and both a and b should be in their lowest form possible. Okay, now provided each and every number that you have meets the above criteria, then it's going to be regarded as a rational number. Why shouldn't we have a 0 as a denominator? Because if we have 0 as a denominator, the entire fraction is going to be undefined. And remember, both the numerator and the denominator should belong to a set of integers. Okay, and integers, we say these are simply positive or negative whole numbers. All right, yeah. So now, as you are studying rational numbers, I want you to have or to know what type of numbers these are. Examples of rational numbers are multiple. Okay, you can have 0.5. This is a rational number. You can have 1 over 3. This is a rational number. 0.3 bar. This is a rational number. And remember, we said when you've got a bar, it means that number is reoccurring or repeating. Why? Because the decimal part of rational numbers is usually going to be reoccurring or repeating, and sometimes it can be terminating or non-terminating, but in most cases it's non-terminating. Okay, but there are certain instances where it's terminating, so I do not want us to take it as such. All right, because in certain instances it terminates and in other instances it doesn't terminate, but in most instances it does not terminate, so it is repeating and non-terminating. Okay, yeah, so these are several examples of these rational numbers that we are looking at. Okay, now what I want us to focus on is how to convert decimals to fractions, okay, or how to prove that a certain number is a rational number. Okay, now to understand that, I simply want us to look at 4 things. Okay, so let's look at some practice questions. Let's say you've been given 0.3 bar, okay, repeated, and they've asked you to prove or to show that this number is a rational number. Okay, the first thing that you do, the first step, I call it equation formation. We are going to call it equation formation. Why? Because in this step, the only thing you do is form an equation. And you guys remember that for something to be regarded as an equation, it should have a what? An equal sign. It should be equal to something. Otherwise, it's going to be known as an expression. So you equate this entire expression to x for it to become an equation. Okay, then the second step is simply going to be, this is step 1. The second step you're going to take is simply going to be identification and multiplication. Okay, and multiplication. Why do we say identification? Because in the given notation you realize that when you've got a number and you want to shift the decimal point to the right of a certain number, you are going to multiply it by a certain number based on what number you want to remain with after shifting the decimal point. And in this particular notation, or in this question that we've been given, we only have 1 digit after the decimal point, and we would like to shift the decimal point 1, or to make it move 1 step to the right of the digit in consideration. Okay, and remember this digit is reoccurring, okay, or it's repeating. If you've got 0.3 bar, it means you've got 0.3333 and it's reoccurring. Okay, so the first thing you do is you realize, or you identify. When you identify, you know that you've got 1 digit after the decimal point. That means you're going to multiply this by 10 for the decimal point to move to the right of this number. Right, others are simply going to tell you that put a 1 while there is a decimal point, and every digit after the decimal point you regard it as a 0. So this gives you a 10. Okay, so you get 0.3 bar should be equal to x, and there is the multiplication part, so you multiply everything by 10. Okay, so what do you get when you multiply 0.3 bar times 10? You get 3.3 bar. Now this is the most interesting part. This number is reoccurring, so if you multiply, if you shift this 3 this side, you still remain with other 3's that are reoccurring. Okay, so this side you also multiply 10 times x, you get 10x. Okay, this is the second step. It ends here. The third step that we are going to have, we are going to call it subtraction. This one is much easier. Okay, so the only thing you do is subtract the first equation from the second equation. All right, I hope you guys get that. The first equation from the second equation. Okay, so what we are going to say is 3.3 bar minus 0.3 bar should be equal to 10x minus x. And what do we get? We get, let's say 0.3 bar, we subtract, we get this cancels, so we get 3. This side we get 9x. Okay, So we've got 3 should be equal to 9x. Then we find the value of 9, okay? The value of x rather, by dividing both sides by 9. So what are we going to get? We are going to get that x is simply equal to 3 over 9. The fourth step is simply going to be known as reduction. Why? Because we said that both a and b are supposed to be in their lowest form possible. In short, there shouldn't exist a number that can go into both these numbers. And in the given answer that we've obtained, we know that 3 and 9 have got a common factor, which is 3. So this is not acceptable. It's not acceptable to leave it at this point. So what you want to do is to ensure that both a and b, remember, if it's a rational number, then both a and b should be in their lowest form. So when you reduce this, you realize that you are going to remain with 3 into 3, 1. 3 into 9 is 3 times. So this is what is going to be your answer. So the aspect of rational numbers of proving, so if you reach at this particular point, what else do you realize? You realize that you've got a fraction in the form of a over b, where both a and b are what? Are integers, because 1 and 3 are both integers, and b is not equal to 0. And if you can show these things and you know that both a and b are in the lowest form possible, then you've proved to say this is a rational number, because it meets the criteria that we talked about. Okay, so this was the first example that we did, and in whatever example you are going to be given, I just want you to follow these 4 steps, and it's going to be easy. So let's do another example. Okay, another example that we are going to do is simply going to be 0.27. So let's assume we've got 0.27 bar. And remember, if you've got 0.27 bar, it means it's repeating. 27 is reoccurring. It's simply equal to 0.27, 27, 27, 27, and it continues. Okay? Yeah. And just for clarification's sake, for those guys that are wondering, if you say 1 divided by 3, see, you get 0.33333. And what did we say? If a number is reoccurring, then you simply put a bar on top of that number to show that it's reoccurring. Of course, I've just brought this calculator with me to show you guys the final answers. As a matter of fact, you're not allowed to use calculators in foundation mathematics. So, given this question, let's simply follow the same steps that we followed. The first step, we said it's equation formation, right? So what do? You simply equate 0.27 to what? To x. Then the second step is identification and multiplication. Okay, so what do? You identify how many digits do you have after the decimal point. You've got 2 digits. So what are you going to do? You're going to multiply, or in other words, you put a 1 here and you put 0 on each and every digit that is after the decimal point. And what do you have? You've got 100. So you multiply this entire equation by 100. And what do you obtain? You obtain 27.27. Remember, whatever is recurring is going to come back this side. And this is going to be equal to what? To 100x. Then you subtract. That's the third step. Subtraction. You subtract the first equation from the second equation. So you're going to say 27.27 bar minus 0.27 bar should be equal to 100x minus x. And what do you get this side? You're simply going to get 27. Okay, 27 should be equal to 99x over 99 over 99. And this is our value, 27 over 99. But remember, our last step, which is reduction, you need to ensure that both a and b are in their lowest form possible. So what are you going to do? You're simply going to look for the value that can go into both these numbers, if at all it exists. If it doesn't, then you're permitted to leave it at that particular point. But if you look at these two numbers, what can you do? If you add 2 plus 7, you get 9. And here you've got 9. 9 plus 9, 18. So it means these two numbers, since you've got 9 and 18, they can possess a common factor. And that common factor is more than likely going to be 9. 9 into 27, it's going to be 3 times. 9 into 9, it's 1. 9 into 9, it's 1. So 9 into 99, it's 11. At this particular point, there is no other number. At this point, use whatever method you think works for you to reduce this into a fraction that is not going to have common factors, where both a and b do not have common factors, or they are in their lowest form possible. Okay, so we are going to do our last example, and this example is going to be a little bit different. So let's say we've got negative 3.532, and the only numbers that are recurring are 3 and 2. Okay, so you follow the same procedure. This is simply going to be equated to x, the first step, equation formation. The second step is identification and multiplication. Now, in this one, you first want to identify the digits that are not reoccurring. Okay, So you see 5 as the only digit that is not reoccurring. So what are you going to do? You multiply this by 10. Okay, so when you put a 1 here and you put a 0 here, what do you have? You've got a 10, because you're first taking into consideration the digits that are not reoccurring. You push it on the other side so that this side you only remain with digits that are reoccurring. Okay, so when I multiply this entire thing by 10, what do I get? I get negative 35.32 bar should be equal to 10x. Okay, yeah. Now, when I form this equation, then I re-identify again. Okay, when I re-identify again, I realize that I've got how many? I've got 2 digits after the decimal point, and 2 digits are going to, for us to move the decimal point to the right of this digit, it has to move it has to make 2 moves, right? It has to shift twice to the right. And if it does that, then we are going to multiply this entire thing by what? By 100. So let's multiply this entire thing by 100. If you want, you can put a 1 here, another 0, 0, then this is 100. So if we multiply, then we shift these 2 digits this side. So we are going to have negative 3532.32 bar. Remember, the digits that are reoccurring always reoccur. Then this side you are going to have 100 times 10x. You are going to have 1000x. Okay, then you subtract. Your subtraction is going to be based on this, the second equation and the third equation. So you subtract the second equation from the third equation. So you are going to say negative 3532.32 bar minus negative 35.32 bar, okay, should be equal to 1000x minus 10x. Okay, when you subtract these figures, you realize that this and this is going to cancel, then these will be additive. Okay, so it's more like you've got 3532 plus 35, which should be equal to 1000x minus 10x, 990x. Okay, when you subtract these two figures, what do you remain with? Negative 3532 minus 35. Okay, what are you going to have? It's like they're telling you take 3532 steps to the negative and go. So you realize that if you subtract this, it's more like they're asking you to take 3532 steps to the negative side. Then you find the positive side telling you to turn back and go to the positive side 35 steps. Okay, so what do you realize at this particular point? When you subtract 2 minus 5, you're going to get a 1 from 3. You remain with 2 and put it here. So it becomes 12 minus 5, which is 7. 2 minus 3, you get a 1 from 5 and remain with 4 and put a 1 on the 2 and get 12. So 12 minus 3, that's 9. Then this 4 just comes down and this 3 comes down together with a sign. So you're going to get negative 3,497 should be equal to 990x, okay, over 90 over 990. You cancel, then x is simply going to be equal to negative 3,497 over 990. The fourth step is reduction. So you check if this figure can be reduced in the lowest form possible. If it cannot be reduced, it means it's in this particular, it's at its lowest form and you don't need to reduce it. So thank you for watching this video, and please, if you've got any difficulties, leave a comment and let me know what you think or why you're having difficulties, and I would be more than glad to clarify and to see how we can be of great assistance. And please don't forget to subscribe, to share these videos with your friends, and to also hit that notification button so that every time we post or upload another video, you guys will be notified on time. Thank you very much. God bless you.